All right. Well, thank you very much, Derek. Just out of curiosity, how many of you are high school physics or chemistry teachers, or just high school in general? Okay, most of you. Okay, middle school. All right. Any elementary? Yes. All right. Cool. All right. Hey guys, elementary's the foundation, right? If she's doing her thing, that means whoever's, you're passing it off. So that's great. All right. So just real quick, I wanted to set this up before I start the presentation. This is my microscope, my laser microscope. So I'm using one of the laser blocks to do that. And what the cool thing is, I don't have to worry about pressing the button, keeping it on. But this is just tap water. Don't think those aren't like microbes or anything like that. Those are just little particles of dust and things. Now, if I see anything with legs, then I definitely don't want to drink the water here. But yeah, those are just little particles. And so you can go, you can get a little shrimp brine, and you can put it on the microscope, and you can see all the little creepy crawlies and stuff like that just using a laser. So that's kind of a cool thing. Okay. So let me go ahead and remove this, and I'm going to turn this off. There we go. Okay. Whoops, got to back up here. I think it just decided to just go through it all. Okay. So there we go. So a couple things about me. So I was a high school science teacher for 5 years. I also taught elementary as a science coach for 2 years, and then I became a middle school teacher, and I was doing that for about 6.5 years. Now, when I started teaching middle school, I was about 6'4", 6'5", about 240. And then after the first year, I lost my hair. I went gray. It was just it's nuts, right? It's worse than a box of chocolates, rotten chocolate. I don't know. But it was really tough. But the thing about middle school, or the thing about my background, is that I've literally taught K through 12. So when I develop lessons, I'm always thinking about how can I scale this down and how can I scale it up, okay? And how can everybody use things? So my last 5 years, I've been a physics bus teacher for Seminole County Public Schools. So we travel around to all 37 of our elementary schools, and we teach mechanics, optics, and electricity magnetism to all of our 5th grade students. The hope is that we get them so excited about science that by the time they're in high school, more will take physics and all that good stuff, and all the engineering courses that we offer. And so right now we've been ranked the top STEM district in the state for the last 11 years because we have such a high percentage of students that get into chemistry, calc, and physics. Okay. So that being said, I want to take you through a couple of lessons here that I do. If you saw the presentation description, we talked about seeing sound and hearing light. So I'm going to explain to you how I do that. Now, some of you that are teaching physics, how many of you actually teach spectroscopy or anybody do spectroscopy? Okay, outstanding. Most of the time you don't see that. Chemistry, you're teaching a little bit of spectroscopy, right? Okay, all right, great. Middle school, anybody doing spectroscopy? But you are teaching a little bit of optics, the electromagnetic spectrum. Okay, great. So knowing yourself, I was thinking about how many of you guys went to the keynote speech? Okay, so that 1% amazing. What I loved about that is I was just thinking to myself about how many times, like when I do my STEM professional development courses, I'll have teachers that'll look at something that I present and they'll go, "There's no way that I could do that like you." And I'm like, "Good. I don't want you to do it like me. I want you to do it like you. Take it and make it your own." So the things that I'm going to present to you today are ideas. Okay, you don't have to do it the way I do. Don't try to steal my jokes. They're probably not very good anyway. But just be yourself, okay? So know yourself, and that's all I ask. So here's the thing about knowing yourself. I decided one day I was going to play around with one of those the image makers, okay? And I decided I was going to describe myself for a presentation I was doing, and well, this is how it came out. It's actually pretty cool. Then I was like, nah, that's probably not very realistic. So I tried it again, and then it came out like this. So I like the fact that he's got the hair on the top. Actually, what do you think? Should I? Yeah, you think that works? Okay, so yeah. So know yourself, right? Anyway, so this is my classroom. And it's very long. It's a big tube. I teach in a tube every day, and it's blackened inside. And this is kind of what it looks like. So I actually put the yoga mats on there because that's where the kids sit. And it's very versatile. I can do all kinds of labs and things like that. But here's the thing. I've been doing this for 5 years. During COVID, we were getting ready to launch our optics bus. We already launched our mechanics bus, going to launch the optics bus. and I've got to come up with some optics lessons. So I'm calling around. I called to a couple of local colleges that had optical engineering programs, and I'm trying to say, hey, what are some things that I could do inside a bus and yada, yada. Nobody really had an idea because it's something that had never been done before. So, so I'm searching around the internet and I'm thinking, man, I want to do some things with lasers and lenses, but I'm going to need a really nice laser, something I can keep on. I don't have to hold it. And so I found Laser Classroom, and I bought a couple of these Laser Blox. These are my original lasers from 5 years ago. Okay, I use them about 15 minutes a day, or 15 minutes an hour, 5 times a day for 5 years. The only thing I have to change on them is the batteries. And they're heavy, they're magnetic. I mean, just fantastic. So I'm going to digress for a moment and let you know that I volunteered to do this. When I found out that the company came back online, because I was terrified that I wouldn't be able to find any more of these, I reached out to Derek. I said, hey, this is what I do, yada, yada, yada. We started talking about the NSTA conference, and I said, if you're going to go, I will speak for you. So I'm not being compensated, other than he lets me wear this jacket to look good, this lab coat, but other than that, I'm not being compensated, so I just want you to know that. So I'm very, very happy that these things are back in business. Now, these are some of my students right there. We're playing with the Slinky. I'm teaching my 5th graders the electromagnetic spectrum using a long Slinky. And then, of course, this young lady right here is a former student of mine, and what was really interesting is I used to do all these same lessons in my classroom, and so when she saw me doing it on the bus with 5th graders, she was pretty excited. And then, of course, these are my kids. Let me see, there's a little video here. So I'm trying to teach them the powers of observation, because what will happen is when I do that little activity, I'll have the kids stand in front of a light and they hold different pieces of paper, and I'll say, okay, forget about what you know. I want you to tell me what you observe. And I'll change the colors, and they'll stick with it. It's a red piece. No, it's not red. What do you see? So anyway, so that's a little activity I do there. So anyway, I can skip this. So yeah, so that's my little story with my laser classroom thing. But I made this little slide for you, Derek, on your behalf. So one of the things, actually the next one. So this is the Laser Blox. Okay, like I said, they're magnetic. They have the line generators, because if you use a regular laser, you just see the dot, but you can't see the line. So it has little line generators there, so you can do all kinds of neat things with that. Yes, I know there are some laser boxes, but the kids really can't see the inversion. So if you use a green laser and a red laser, they can see that when the lasers pass through something, they invert. Okay, so this helps. And then, of course, the light blocks. How many of you come by the booth? Okay, about maybe a third. Okay, this is going to be great. You guys are going to love this. Okay, so we're going to demonstrate. We're going to try and get a little demonstration in on the light blocks too. But what's really cool about these are LEDs, and they have a cover with a slit in it. So there's a lot of little things you can do with lines. You can do color mixing, and we'll show you some activities, okay, that you can go back to your classroom and do. And then, of course, this is the Tech Light Lab. So if you come by the booth, you can actually see this in action. But it comes with all of these things. So you've got red, green, blue, and then you've got some lenses you can use, and a protractor. And it's a really neat classroom hands-on activity. So if you have five or 6 or 10 of these in your classroom, the kids can actually do these things. So you don't have to worry about somebody shooting a laser in their eye or things like that, okay? So to the rescue. So back to this. Derek, this is for you, man. This is for you. Let me see if I can get this going. It didn't work. It didn't work. Ah, well, there you go. Anyway, so what was crazy was when I first saw this, now he also... There you go. All right. So what was crazy about that is when I was talking to him, and he told me that he also had the Genius Lab Gear company, and I saw these lab coats. I was like, oh my gosh, I got to get one of those. And so he lets me wear this. It's just the coolest thing ever. Okay, 30 seconds or bust. So here's the thing about what I do. I see 5 different classes a day, kids that I've never seen before. We have 9,000 students that pass through our buses every year. And I have to captivate them. I've got to engage them 30 seconds or less. I absolutely have to. So what I'm going to do is I'm going to run you through my presentation with them, kind of model how I engage them, okay? And just know, like I said, I've got 30 seconds or so to captivate their attention. So yeah, so we'll go ahead and I'll go ahead and start on this. So engagement's the biggest piece. Activity before content is my game, okay? If I don't do an activity before content, what you end up doing is you lose a lot of your kids, the special needs kids, you lose the kids that can't read, you lose the kids that are hangry. But if you do something wild and crazy when they come into your classroom, if you just one little thing every day, wow, you captivate them, you get their attention, and you have more interaction. And you know what? Engaged kids are not behavioral issues, right? Does that make sense? Okay, so here I'm going to Title I schools, I'm going to the cream of the crop schools. It doesn't matter. It's a mishmash every time I go. So here's how I start it. So the kids will come out, and I'll say, "Good morning, guys. My name is Mr. D. Welcome to the reading bus." And then what do you think happens right there? You know, they're kind of like standing around, and then they hear reading bus, and they're like, "What?" And I'll go, "Okay, all right. So what? You guys don't want me to read to you? What would you rather do?" "We want to do science. "Oh, you guys want to do science? Okay, well, why don't we do science?" "Well, my name is Mr. D. I'm the optics bus teacher for Seminole County. And today we're going to learn about lasers and lenses and all kinds of cool gadgets, okay? And so in order to do that, I'm going to have to teach you guys a little bit of elementary science, a little bit of middle school science, and a little bit of high school science. And you know what? If we have time, we're going to do some college level physics." And by this time, they're like, "Oh, wow, that's pretty cool." And then I'll say, "And before you leave, we are not only going to see sound, but we are going to hear light. We're not going to sniff crayons and smell colors, but we're going to see sound and hear light." And now I've got their attention. They're like, "Oh, wow, this is so cool." And then I just give them a little rule that, when you're inside the bus, if you hear my voice, zip it, lock it, put it in your pocket, and, things like that. Then they go on the bus, and the first thing that happens is two things happen. I've got my LED lights going. It's dark in there. They're flashing. I've got some lasers going on. And the kids walk in, and they go, "Wow, this is the coolest. It smells nice in here." Those are the two things. So I always, when I teach in my classroom, I try to appeal to as many senses as I can, okay, to make that memory. And it's amazing how things will stick, okay? So we'll get into Roy G. Biv. So I'll start off by talking to the kids about, you guys know that white light that you see bouncing around here is made of the colors of the rainbow, right? And then I will ask them, "Do you know a way to remember the colors of the rainbow?" And maybe one child will say Roy G. Biv. Oftentimes they don't know it all. And I'll say, "Okay, it's Roy G. Biv." So then I'll take a piece of paper like this, and I just ask them a simple question. Now I'm going to uncover some misconceptions. And I'll say, "Okay, guys, so here I have a red piece of paper," or I'll say, "Here I have an object. This object is a solid rectangle. Would you agree?" "Yes." "Is it thin and flat?" "Yes." "Is it flexible and light?" "Yes." So they keep on going, and I say, "Is it wrinkly like me?" And then they say, "Yes." "No, wait." And that's how I know if they're listening or not. And then I'll say, "Okay, is it red?" You guys agree with that, right? And then I'll say, "Okay, now if I turn the lights off and it was pitch black in here, would it still be a solid rectangle? Would it still be thin and flat? Would it still be light and flexible? Would it still be red?" And they agree with everything until they get to that point. "No, yes, no, not." Middle school, even high school, okay? Because you got to understand, if you're a physics teacher, who taught them this stuff before they got to you? Think about it. Did they learn this in biology? Were they taught it in chemistry? Maybe a little bit. Were they taught it in middle school? Maybe. Okay. So oftentimes you get students that have never had really a lesson in light by the time, when they're in 12th grade physics or 11th grade physics. So anyway, what I'll do is I'll turn the lights off and I have them observe. I keep the lights off for about 30 seconds and I say, "Did you guys notice how your eyes are adjusting?" And they, "Oh, wow, I can see glow-in-the-dark stars. I can see stuff. Great." But then I turn the lights back on and I ask them, were you able to see the red piece of paper? Were you able to see any colors at all? No. Then I ask them to finish this statement. "In the absence of light, there can be no color." Boom. Okay, so we've established that the only time you can perceive light is if you, or perceive colors if you have light. Now, the next thing that we'll do is I will call up a couple of volunteers. Would you be able to get the lights for me? Can you do that? So I'm going to need a couple of volunteers. It won't hurt too bad, but I just need, do you mind coming up? Come on up. Can I have maybe one other volunteer, possibly, sort of? Would you come up? All right, great. This is going to be kind of rough, but we'll make it through. Okay, so here's what I want you to do. I want you to hold red, and why don't you hold red and, let's see. Actually, we'll do it this way. Instead of doing that, I'm going to have you hold this, okay? And then I will have you hold these two, and I'll take red back, okay? So I want you to stand behind these light bulbs, and I'll move this off to the side for now. Okay, so you're going to stand up close there, and yeah, that'll work. Okay. Now, go ahead and hit the lights. All right, and then I'm going to have to cover this up. Is that as far as they go? Well, this isn't going to work. They told me I could completely darken this place.
Yeah, I did mistakenly turn off a light in one of the rooms.
You did?
Yeah.
Just start banging on them. Oh, there is? We're science teachers. We can figure this out. Somebody's going to be screaming next door. I don't know. Okay. So we'll picture this, okay? Because I don't want to take up too much time, but let's just picture this. Okay, so what I'll do is I turn my LED lights on, okay, and then I start to change the colors, okay? And you can kind of see that the colored one is changing a little bit, okay? It's kind of hard to see that, but you also notice something else, and we can probably even pull it off here. You see the black never changes, okay? But what's the white doing? It's changing, whatever color, right? So now this is a great opportunity for me to talk about we need to set the mood. And we'll need to be able to turn them back on too, maybe. Might be a good idea. Not working, huh?
They're set. They're not good. They have to leave the electricity in to turn them all. Sorry.
Should have brought my bus. Okay, so yeah, so yeah, there we go. No, we're not going to shoot them out. Okay, so the whole point is the kids are sitting there. They see the colors changing, but they see that white is changed. It's becoming whatever color is reflecting off of it, and black is just staying the same. So now I can explain black absorbs, white reflects. Okay. Now this really stinks because there are a lot of things that I can't do now because I can't turn off the lights, and that's horrible. But anyway, so what I like to do too is I'll give the kids each a different piece of paper. I'll have like 5 kids stand up, like you saw in the video. They'll hold the piece of paper up, and I'll say, okay, when I call out a color, hold your paper up, and I'll call out orange, and I'll dial the lights so that red, orange, and yellow appear to be orange, but the kid holding the yellow and the red, they won't hold them up because they'll argue with me and say, no, it's yellow. But what does it look like? It's yellow, but what does it look like? Because they're just not grasping the concept of just what do you see right there and now, okay? All right, you guys are excellent. Thank you very much. I appreciate it. Okay, so now that we've talked a little bit about black absorbs and white reflects, the next thing that I like to do is find my lasers. Here they are. These are remote control LED bulbs. You can just find them on Amazon. Yeah, just look up LED remote control, color changing. Yeah, you want the color changing? Yes, definitely. Okay, and that's all you have to do. So it's not a very complicated thing. It's going to be kind of difficult that I can't turn the lights off doing some of the other things. But the next thing that I like to do is I'll have my lights off in my bus, and I will say, okay, you guys can see those dots, right? But you can't see the beam. So this is an aerosol spray. It's a photographer's haze. Okay, you can get this on Amazon. You can get like 2 cans for $36, but they'll last you forever. Okay, and what you can do is you can kind of start spraying this out, and now you can see the beam. Now, what's really cool about this, if I use my line generator, is I can show them how the gas expands to take the shape of the container. Okay, and when it's really dark, you can really see it just go all the way across the room. Okay. Oh, absolutely, absolutely. In the dark, it's a phenomenal effect. And so the other thing is, like right now, you can see the line. And what I'll do is I'll have the kids, I'll say, okay, with your hands and feet down, I'll bring it up to their eye level, and I'll say, can you see the sparkles in the beam? Yes. And then I'll go over to the other side, and I do the same thing. Can you see the sparkles in the beam? And I say, well, those sparkles are actually particles of mineral oil that the beam is reflecting off of and scattering. Because in the dark, when you look at it too, there's like a glow around the beam. Okay, so that's kind of the scatter. And then I can turn around and I can use that to talk about why the sky appears blue. And so when Roy G. Biv comes down from the sun and it hits our atmosphere, it does the same thing. It's reflecting and scattering. That blue wavelength is reflecting and scattering. Okay, when I say reflecting, because when you look at the Earth from the moon, when you see those pictures, you can see blue, right? Okay. So anyway, so that's kind of a neat thing that I like to do with the kids too. And then of course, they always want to reach out and put their hand in there, and you know, that's kind of a fun thing. But it's a really neat effect and it just really captivates the kids. Okay. So the other thing that I can do with this is I can talk to the students about energy levels and humidity. So my son and I, we have this really nice telescope, and we love to look at the night sky. And I like to use the green laser to point things out to him. Now, what we've noticed, though, is that on a warm summer night, it's a lot easier to see the green beam than on a cold winter night. What's in the warm summer air that you don't have as much of in the cold winter air? Humidity, that's right. So the kids, they relate that, and they're like, oh, wow. Now, a lot of them will know it, but it'll be on the tip of their tongue. So sometimes I have my word wall, and I just reach up. I have magnetic words stuck to the ceiling, and I just grab them here. Humidity, okay? Now, the other thing about it is, I'm going to tell you right now, I don't care what grade level your kids are. Sometimes, if you say a word, you know, like, for example, the word inertia, a kid that's never seen it before, what does that sound like? I-N-E-R-S-H-A, maybe? So you can't, if you're introducing to the language of science, you got to have those words up too, okay? Never assume that they know something, okay? All right, so enough of that. So that now we're going to hop into lenses. Now, here's the thing. If I just start talking about convex and concave lenses and reflection and refraction, sometimes it goes right over their head. So instead, what I'll do is I'll say, okay, guys, now we're going to talk about lenses. And the two lenses we're going to talk about today are a convex and a concave lens. Now, the convex lens is very similar to a magnifying glass lens or the lens in your eyeball. Not quite the same, but you know, it's close, okay? And the concave lens is kind of, if you look at it, it's kind of caved in. It's kind of the opposite of the convex, so they kind of fit together nicely. Now, the reason I'm talking about these two is because the very first telescope that was ever invented back in 1609 by Galileo used a convex and a concave lens. And I'm going to show you how light travels through each one of them. But before I do, I want to make sure that you guys understand the vocabulary that I'm about to use. So, what do we call it when light bounces off of something? Now, again, physics teachers, just bear with me, okay? What do you call it when light bounces off of something? So it's reflection, right? Now, what about when I have a cup of water with a straw in it and the straw looks bent or broken? What do we call that? Now, the kids will always say like bending. Some of them will say refraction if their teacher's pretty with it. But here's the thing. Kids typically remember refraction up until a test. Then they brain dump it and they stop using it, okay? So what I do is I break down the word and I take refraction, I hold it underneath reflection, I show how they're very similar. It's just the LE and the RA. So then what I'll do is I'll cover up the RE and the ION, and you see the root word fract. And I'll say, guys, this is also the root word of fracture. How many of you have ever had a broken bone before? Oh, it's a fracture. Okay, great. So it's a break, right? So refraction is the bending or the apparent breaking of light, and it happens when anytime light travels from one substance to another. Let me give you an example or a way to help you understand this. Let's say I took you all to Daytona Beach, okay? And I line you up on the beach and I pick Daytona Beach. Has anybody in Philadelphia anybody here ever been to Daytona Beach? Okay, if you know anything about Daytona Beach, it's very hard and flat. You can drive on it, okay? And so I line the kids up on the beach and I say, okay guys, on the count of 3, I want you to run into the water. So they run into the water. As soon as they get to the water, I say, okay guys, what's going to happen? Are you going to slow down or speed up? And they know they're going to slow down. Okay, and I explained to them it's because you're going from a less dense substance, you're going from air to a liquid. Now I put it in a perspective they can understand. I painted a little picture for them, and they don't forget. Okay, you have to do that. If you throw out refraction, you throw some examples out there, it's just going to kind of go in one ear and out the other. But if you give a practical application, something they can see, something they can visualize, a picture in their minds, it's going to stick. Okay, now, so then I'll start off. And I will show them a diagram of the human eye. And you can find these, I think I got this one off of Canva, okay? And all I want to do is point out that there's key parts. You have a retina, okay, this is where your rods and cones are. Then this white part here is your iris, or I'm sorry, your lens. In front of that is something called your iris. And then this part is called your cornea. And that kind of acts like a little bit of a lens as well, okay? And then what I'll do is I'll talk about how when light enters your eyeball, okay, and if your lens is working properly, all this light should converge, should come together right on that retina. If it does, then you have good vision. But if it's too far forward or too far back, guess what you need to wear? Glasses. And then I'll look around the room and I'll have like 5 or 6 students that have glasses. And I'll say, you want to see what the light looks like as it passes through your glasses? Yeah. And so I can tell if somebody's, if they need reading glasses, they need to see, or they have distance glasses. And I can, let me get my line generator going. And so I can put my glasses down here and you can kind of see how can you see them converging? Okay, so they're converging a little bit. See, they're not too bad. And then if somebody has trouble seeing distance, they will diverge. So the kids find that really, really interesting. Now, the other thing is, you wouldn't believe this, but there are a lot of students that don't even realize they have a pupil because they have very, very dark eyes. So this is an opportunity for me to talk a little bit about genetics. And I can mention to them that, how many of you have brown eyes? Okay, I'm pretending you're my students. Okay, so if you have brown eyes, that is a normal gene for human beings. That's the normal. That's the most common. Okay, how many of you have green eyes, blue eyes, or hazel eyes? Okay, like me. You're the cool ones. No, I'm just kidding. So you guys are kind of like genetic mutations. You're the recessive gene. Then I can go into genetics a little bit. You see, when if I just teach optics, if you think about it, if you just teach physics or you just teach biology or you just teach chemistry, you've partitioned everything out and the kids don't see a relation, right? So I'm throwing all this stuff in there. I'm mashing it up. So I'll talk a little bit about that, and then I'll talk about the iris. And here we go. So I show this one because, again, a lot of the kids, they have like really dark brown eyes, they don't really realize they have an iris. And if you look closely at the iris, it's kind of crazy because it looks like a net. And they also think the pupil is something solid, but it's just a hole in your eyeball. Okay? And I'll talk to them about how, remember earlier when we turned the lights off to see if you could see the piece of paper? And your eyes started to adjust. This works great if, in my classroom, I've always put glow-in-the-dark paint all over the ceilings and floors and walls to look like stars. So when I do this activity and I turn the lights off, as their eyes adjust, they start to see more and more stars. Now, human beings, how many of you are into astronomy? Anybody know how long it takes for the human eye to completely adjust to a dark sky environment? How long? It's insane, right? It just takes you forever. But this guy right here, does anybody know what this is? Cat. These guys are like almost instantly. Okay? And then anybody know what this is? So now, what about this? What's that? It's an octopus. It's an octopus. So now so guess what the kids do when they go home? They go home and they look this stuff up. Or when they go in the classroom, they look this stuff up. Okay? So, it's not all. So this is a little bit of biology, a little bit of anatomy, physiology, etc., a little bit of life science. So I throw that in there. So we talked about that. And then I can also talk about why pirates wore eye patches. Does anybody know why they wore eye patches? No.
Really? Or the story? Theoretically, so they always had one eye that was adjusted to the dark.
No. That's the real reason is because, eye patches are cool. They're really cool. No, actually, I like to wear them when I'm driving down the road, down the highway, the 417 or the I-4. If you know anything about Florida, it's like if you're doing 85, you're way too slow. And sometimes I wear 2 eye patches. Only when there's guardrails, though. Okay, so you guys aren't buying that. How about this one? So most of the pirates that wore eye patches, they had hook hands, okay? And so what had happened was they would get their limbs cut off and they tried to make it a useful limb, so they would attach a hook to it or something like that. And because they weren't used to it, sometimes if their eye itched, they might reach up and pop it out like a marshmallow on a stick. And so they'd have to wear an eye patch. And now the kids are like, what? And I'll say, you don't think that's a good one either? Okay, well, I guess we have to go with that one, right? So they could see better at night. So think about this. when your eyes adjusted to the darkness when I turned off the lights earlier, then I turned it back on, you were kind of like this, right? Now, imagine you were in a bright, let's say you're on a ship in the middle of the ocean. It's very bright outside, in the middle of the day, and you have to go down into the ship's hold to get something. Well, it's going to be pitch black down there. If you wore an eye patch, it would allow your eye to adjust to the darkness. So when you went down below decks, all you would have to do is flip it up, and you'd be able to see. Ah, okay. So I painted a picture, told a couple stories. They're laughing, okay? Remember, again, keynote speaker. When you watch that guy, he's telling a bunch of stories, right? And you're picturing everything. And that's how you get things to stick. You got to be a storyteller. All right, so anyway, so we talked about convex, and then I can ask them, okay, so if the convex causes the beams to come together to converge, what do you think the concave is going to do? Oh, sorry, didn't mean to give it away. And they'll go like this, and I'm like, no, don't flash any gang signs. Just tell me what you think. And so I'll have 3 or 4 kids that'll go, well, they're going to separate. And I'll say, are you sure about that? Are you really sure? And what I'm doing is I'm pushing them to see if they're going to change their mind, because the kids that do well on tests don't change their minds. And I'll push and push and push, okay? And they'll change their minds. Some of them won't, and I'll ridicule them slightly. Are you crazy? You think they're going to separate? Is that the best that you can do? And and some of the kids will stick to their guns, and some of them are kind of like, ah. And then I show them, and then they see that they do separate, and the kid that was right is like, yeah, and I'll go, man, I'm proud of you for sticking to your guns and not changing it. Now, the other thing that I do, I'm going to tell you right now, this is the greatest thing that I think I do for my students, okay? After I ask them a few questions, I will say to them, I'll turn to the teacher and I'll say, is this like an advanced or gifted class? And I watch the teacher. If the teacher says, yeah, then I know it's an advanced or gifted. If the teacher says, are you kidding me? Then I know the teacher's not with it. And I know that she has behavioral issues and things like that. She has problems with classroom management. If she looks at me and she says, oh yes, they're gifted. They are special in their own way. Then I know that it's a good teacher, but it's a regular class. And then I will say, if I didn't know better, I teach 9,000 kids a year, and I would have sworn you guys were an advanced or gifted class. And when I do that, do you want to know what happens the rest of the time they're in there? I'm a stranger, right? They're on it, they're asking questions, they're participating, they're excited, they're happy, they're engaged. Okay? I'm telling you, man, you want to flip the switch on your kids, you tell them how smart they are, and of course, we want them to be intrinsically motivated too, but anyway. So, enough of that. So we talked about lasers and lenses. The next thing we're going to do is we're going to talk about sound waves, okay? So here's the thing. When I teach the kids about light waves, I also want to teach them about sound waves. So what I actually have, how many of you have a giant slinky like this? Yes, okay. If you don't have one, well, you're really missing out. How many of you tie a ribbon to the center? Do you know why I have the ribbon tied to the center? Yeah, so the kids can see which way the particles vibrate, right? And they can also see, because the misconception is that when a wave travels across the ocean, that it's carrying matter. Okay, so I can show them it's just vibrating in place. It's not going all the way back and forth. So what I like to do is I have them put their hands on their throat. Okay, go ahead and put your hand on your throat. All right, now what I want you to do is I want you to give me the deepest energy, deepest frequency, or the lowest energy, lowest frequency, lowest pitch, deep bass you possibly can for 2 seconds. Ready, go. Okay, now I want you to give me the highest energy, highest frequency, highest pitch hum you can. But keep your mouth closed, otherwise it'll sound like a Taylor Swift concert, and we don't want that in here, okay? All right, so here we go, 2 seconds. Now, I don't know about you, but I couldn't feel those high frequency vibrations, right? Okay, and so then I can show them with my slinky, low energy, low frequency, low pitch, and I can talk about, look at the distance between the waves, and then I can talk about the higher frequency, higher energy, higher pitch. So now they can see the relationship. Now, I'm going to give you a quick tip on formative assessment. If I say to the kids, what do you call it when a sound wave bounces off of something? Sound wave bouncing off of something, they don't really think that way. But if I say, what's the term we use to describe when, let's say we walk into a cave and we go, hello? They know that. So if I assessed them the first time, the first way, they failed. they've all failed. But if I assess them the second way, it's an echo. So they know it, they just haven't, put the connections there, right? So I'm always careful about how I assess the kids. I have to make sure that it's relevant to what they know. Okay, so the next thing we're going to do, and then of course I'll go through the electromagnetic spectrum. And I will take the slinky and I will go, I explain to them that, hey guys, we can only see about, like 0.0035% of all the light that comes from the sun, okay? And the rest of it is invisible to us. And that's important for what we're going to do next. And then I'll go through radio waves, and I'll talk about as I'm going, as I'm changing, and I'll say, and then microwaves, a little bit higher energy and higher frequency. Notice I haven't defined energy or frequency, okay? So as I'm going, I'll say, look at my hand. I'm putting more energy into this, more energy. And then I get to infrared, and I'll say, now you guys can't see infrared. It's invisible to you, but you can feel it. It's the heat you feel from the sun on a hot summer day when you wear a black shirt, okay? In the state of Florida, the kids have to know infrared, visible, and ultraviolet in middle school. Okay, those are the key ones they need to know. So I'm focusing on that, right? And then I go through the visible light, and there's red, orange, yellow, green, and then I say, notice, you see how much more energy the green has than the red? That's why the green was so much brighter and easier to see than the red. Okay, and then I keep on going. I go to violet, and violet's got a lot more energy, and that's important for something we're going to do a little bit later on down the road. And then I go, now we're getting into ultraviolet. Now we're moving really fast. Ultraviolet can give you a sunburn. And then we have X-rays. And last but not least, we have high energy, high frequency gammas. Look at the energy that's going into this, guys. Isn't this crazy? And then I'll ask them, which one do you think is most dangerous to humans? The last one, the gammas. That's right. But that picture, they don't forget that because I'm running into kids now that I had 3 or 4 years ago in middle school. And they remember this stuff like it was yesterday. Okay? Because I painted a picture, I told a little story, they visualize it, and we move on. Yes?
How do you explain that they can hardly see the violet laser?
So, okay, so as far as I typically don't show them the violet laser, but I tell them, look, you're getting very close to becoming invisible again. It's very close to a wavelength that you can't see. It's a much higher energy and a much higher frequency, and so it's getting right to the edge of what you can't see. So, for example, if you have an ultraviolet light, like this ultraviolet light, and my ultraviolet light died. Wow, okay. I had all my bases covered, but I'll say, I'll talk to them about ultraviolet being invisible, but then I turn this on and they can see it, and they're like, why can we see it? Well, you have to have a little bit of visible light, kind of so I know that it's on. Otherwise, I could be, and it gets warm too, and I could feel it. But so much for that. Darn. I thought I had all my bases covered. All right, so now I've talked about all of those. Now we're going to see sound. Now this is great. This is a drum. It's a 6-inch PVC pipe, okay? I stretch a latex balloon. I get like a 36-inch one. That way it's got a little bounce to it, and it's pretty durable. And then I have a little mirror right there. And where did I put the one with the stand? Where did I put that? Okay, and what I'm going to do here is I'm going to take my Bluetooth speaker. Oh, there it is. And I'm going to put it inside the drum, and it's going to transfer its vibrational energy to this surface. And let's see. Actually, I think I'll move this back here like this, and I'll try my best not to shoot anybody in the eye with a laser. We'll see if I can get this. See if I can get this just right. Okay. Let's close this a little bit. All right, everybody close their eyes. Okay, I'm pretty close. I'm almost there. I have a little stand that I use, but I just couldn't fit it in my suitcase. All right, there we go. So there's my dot. All right, this is great. This is so great. Now this is, the thing about this, I'm going to explain to you, using this, I'm going to explain to you why the divorce rate is so high in this country, okay? So the first thing we're going to do, and just bear with me on this, I'm going to play some tones for you, some individual tones. So if you check this out, right now we're at 24 hertz. It's still too low to see many vibrations, okay? And now we're at 40, and now you're going to start to see a little movement. And now we're up to 50. 60. Now, here's the crazy thing. What you're going to notice is that every frequency has a different pattern. This is what the surface of your eardrum is doing when you hear this, okay? Now, if you want to add a little more fluff to it, you can just take your, again, we're not going to be able to see it in here, but you can kind of show this to the kids, and they can really see it, and they can see all the haze kind of floating through it. It's a really cool effect. So I'll take it up to 80, then I'm going to take it up to 90, 100. Okay. Now, when we did the hum test earlier, you could feel the low frequency, but you couldn't feel the high frequency. Check this out. Let's take it up to a high frequency. See how tiny they are? They're compact, all right? A lot of higher energy, but they're really packed close together, so it's not going to penetrate your tissue. You're not going to feel that, okay? So now, we're going to do something else that's kind of interesting. We're going to do the hearing test. Now, ladies and gentlemen, very important. Classroom management. This is something I learned my first year, maybe my second year teaching, okay? It turns out that human beings, once you reach the age of 25, a couple things happen. And this is very important, ladies, for you to pay attention to. Once we reach 25, two things happen. Most males, our frontal lobe fully develops and we stop doing stupid things, for the most part, okay? So we stop, we stop taking chances, things like that, and we kind of tone down. But the other thing is we start to lose our higher frequency hearing, okay? So ladies and gentlemen, what happens is since you have higher frequency voices, later on, we might not be able to hear you. So if you say to me, for example, honey, will you take out the trash? Man, I'm not going to hear that. The football game's on. Okay, so here, and 100% of husbands agree with me on this. So what you got to do, ladies, what you got to do is when you want your husband to take out the trash, for example, all you got to do is say, honey, take out the trash. If you say it that way, I promise you he will move. Well, he may run out the door and not come back, but he will move for you, right? So we start to lose that higher frequency hearing. So now, this is a great classroom tool to use. So I'm going to take this up to about 12,500 because I can't hear that. It's bliss for me. And here we go. This is 13,000 hertz. You're not going to see anything up there. Can anybody hear that? Really? Oh, now you hear that? Well, now I know who all the young whippersnappers are. Sorry about that. Now you know you're alive. I apologize. I didn't know I would have that effect on you. All right. So enough of that. Now I'm going to play a song for you. I'll play a couple songs. So this one is near and dear to my heart. I play this for everybody. Here we go. Maybe. Okay. So sometimes when this happens, I have to get out of my Bluetooth and go back into it. Do you want me to sing? Okay, I'm going to sing for you guys. All right, maybe. Wow. So I always know I'm doing something right when I have technical difficulties.
Absolutely.
That is the story of my life. Here we go.
Also, I want to let you guys know I'm recording the whole session. It'll be on our YouTube channel and on YouTube.
Oh, awesome.
You didn't tell me that. Oh, that's right, man. I don't want to.
But YouTube just at Laser Blox Laser. You can follow them, and we'll start putting more videos to download on there.
I did a hearing test with my sixth graders. I once posted the link online and said tried it at home, but the kids were doing it in other classes. They would post the hearing test.
Yeah, you don't want to.
Oh, my head hurts. What are you talking about? And they were torturing each other.
Yeah, you don't really want to tell them what you did.
We have one-to-one classes.
Okay. Yep, I know. Okay, there we go. Isn't that great? So you have all now officially been rickrolled, so you can go back home. That's probably the only thing you're going to remember is that you got rickrolled, at NSTA. What does that mean? And then, of course, this song was terrible. I had just gotten done doing a professional development training for some teachers in Daytona Beach. It's during bike week. There's bikers everywhere. I'm done. I got bugs on my windshield. I pull up at this gas station to scrape the bugs off my windshield. I got this on my phone, my Spotify, and I don't know if you know anything about Spotify and phones, but sometimes you're driving down the road and it just spontaneously comes on, okay? So I'm there, I got my car running, I open the door, and all of a sudden this song comes on. Now, I'm kind of an older guy. I got no kids in the car, and there's bikers standing around. Needless to say, I got in my car and I just drove off, and that was that. So there you go. So that's seeing sound, okay? Now, I mentioned before about hearing light, so I have this little apparatus. You guys are going to love this. So this is a solar panel hooked up to a Zoetech speaker. It's a mini amplifier. You put it on your belt, okay, and then you have your little headphone. You can get it on Amazon for about $34. So they're hooked up, and what I'm going to do is I'm going to point. I can't do my ultraviolet, but I have a couple of infrared remote controls. Now, again, I told you before, as human beings, it's invisible to you. But if I point here, now you can hear it, right? Here's another one. Okay, so now you can hear two different ones. So that opens up. Why did they sound different? And what I'm trying to get at is they're different frequencies of infrared. Okay. Now the ultraviolet. Earlier I was showing them here's infrared, here's ultraviolet. So they understand the relationship between energy, frequency, and pitch. So then I asked the kids, these are fifth graders, if I shine an ultraviolet light on here, what do you think is going to happen? What kind of pitch do you think it's going to put out? And they all say high pitch. They just know it. Okay. And so that is hearing light, seeing sound, hearing light. Okay. Very easy to make. If you need tips on doing this, I can definitely help you out. Okay. All right. Now the last thing that I want to talk about is spectroscopy. Okay. What you can do, and I don't have any here, but when I'm teaching my kids spectroscopy, how many of you guys have one of those spectrum tube lamps? Okay. Raise your hand high so I can see. Who does not have a spectrum tube lamp? Okay. Yeah. Go ahead and just hold that thing up. All right. So what you can do. I forgot something here. Let me grab this real quick. What's that? Yes, they are still available. You can get them at.
Next generation science.
Yeah, I know Arbor Scientific puts those out, but you can take. You can get rainbow viewers like this, which are not. They're not as accurate as the. Where is yours? Where's your square one? Like for high school, I would want to use the square diffraction grading, but these are called rainbow viewers. You can get 50 for like $20. Yeah, but it's just a little black or a little square one. You've seen those before. But what you're going to do is you hold these up and show them different light bulbs. Look through the different light bulbs, okay? And what you explain to them is that every light bulb has a different rainbow, right? Some are missing red, some are missing blue, etc. Just like every light bulb gives off a different light, every element on the periodic table, when you heat that gas up, it gives off a certain rainbow, okay, a certain spectra. And then I'll go through and I'll show them that, and then I explain to them the reason that's important is because that allows us to look at a star's light, and we can tell what that star is made of, even though it's hundreds, thousands of light years away. And the other great thing is, if you want to get into the astronomy portion of it, you could hold a star, like I don't know, put a ball on a stick and put another ball on a stick, and you can talk about the transit method for how they detect planets. How many of you are familiar with that? Okay, so basically what happens is if a planet passes between the plane of that star and the Earth, we can actually detect a slight drop in the light that's given off by the star. But we can also analyze that starlight passing through that planet's atmosphere, and we can tell what the planet's atmosphere is made of, even though we cannot see the planet. Okay, pretty cool stuff. Okay, so that's kind of the extent of what I do with this. The other thing that we can do, I love this because you can set up little stations. This is something I just learned from Derek. But do you recognize these boxes? Little $5 Target box, right? Little storage box. It's a little black box. And what you can do is you can set up a little, maybe. Yeah. Maybe set those up. But what you can do is we have a red, blue, and a green light blocks, and you can point them in there, and we have the colors of the rainbow on the back, and the kids can kind of play around with mixing colors. And what's really, really fun to do is take some M&Ms, give the kids bowls of M&Ms, okay? Turn the lights down and give them each one of these and have them sort the M&Ms. Say, okay, I want you to pull out the orange M&Ms or whatever. Then you turn the lights back on, and they're like, oh, and they're not orange, they're red or they're yellow or something. So that's one activity you can do with that. Another activity is, this one's kind of neat, using the violet light. So the violet light, there's a couple things. This violet light's really cool, but because it actually will, it'll actually, I don't know if you guys, yeah, you might want to walk around and show them, but you can actually excite these glow-in-the-dark little dots, and you can actually draw on them. You can also take a violet light, a violet laser, and you can point it at your polarized lenses, and it will actually excite the polarized lens, or the transition lens, yes, and it will darken it. Okay, so it's pretty cool. Yeah, yep.
I had one better than one other kid.
Yep, absolutely.
And you just cut out the back and then put.
Well, these boxes come with a detachable base so that they can collapse. So you pull that out, put stickers on it, I put it off a piece of paper, double-sided tape, put it back in there, and then you can just stick it on it when you collapse it.
Yep, pretty cool stuff. Let me check something here. There we go. All right. Yep, we got 6 minutes till they kick me out. So I have a couple more things that I want to share with you. All right, because I may never see any of you again, and I want to make sure that I pass on as much as I can to you. All right, so when I'm talking about spectroscopy, one of the really cool things to talk to the kids about is basically how many stars there are. So if you look at the top number, it's, you know, we estimate there's somewhere between 100 and 400 billion stars in the Milky Way alone. Okay, and we also estimate there's probably, you know, at least 1 trillion galaxies in the observable universe. So if you assume that every one of those galaxies has that many stars, then you get a number 4 followed by 23 zeros. That's how many stars, you know, we estimate to be in the observable universe. Now, that's about 100,000 times more than all the grains of sand on the face of the entire Earth. And I'm talking, you know, the deserts, the oceans, the beaches in Florida, your backyard, okay? So when I paint that picture, when I talk to the kids about that, and then I say, and every star is different, when we look at them using spectroscopy, it's like mind-boggling for them. But it's like, it's just a cool fact, and you should see their eyes. It's weird seeing a whole class of kids with their eyes rolled back in their heads, but it's just absolutely fascinating to them, okay? So I love to throw little things, little snippets out there like that to them. All right, so the last thing, we talked about that. We talked about laser microscope. I showed you guys that early on. Okay, I'm going to go here. So this is, so if you want to get that QR code, you can download the 27 lessons that Laser Classroom has. And there's actually, we're going to be adding some more to it as well.
It's the same one that's on the protractor, and it's inside of the book too.
Yep. And if you want to come by and you know, play around with some of the lasers and handle them and see what they're like, it's booth 754. Okay.
So we'll probably be there like 10:30 to 1 today.
Yeah. Yeah. We'll stay longer if you bring donuts. If you don't, we're 1 o'clock gone. And then if you need anything from me, that's my website, my LinkedIn. And I do one of the other things I do is I have a STEM education consulting company, and I give STEM courses throughout the state of Florida. So this year we're doing like 20 of them. And so I have, you can find all the syllabus there. So if you want to take a vacation in the summer, do 3 days of nothing but hands-on activities, you're going to have blisters and calluses. I'm just letting you know ahead of time. But you know, you can learn how to make this guy, if you want to see your voice. Hello. Woo. So that's a seeing sound device. So we make a lot of cool things like that. All right. So any other questions, concerns? Everybody take those pictures so I can close it.
Can we continue in the hallway for another couple hours? Because I can listen to you.
Yeah, so thank you. I appreciate it. Thank you. But again, a lot of this, if this guy wouldn't have showed up, you know, I don't know. But hey, what do you guys think of my lab coat, man? Maybe I can convince him to let me keep it. What do you think? The collar? Yeah. Yeah. So, well, I appreciate you guys coming. Do you have a question?
Yeah, it comes in a
Yep.
box set. Those are just 2. There's like 5 or 6, and they're in a nice wood box. We've got a whole set that you can look at.
Yep.
I can give you a testimonial on Laser Blox. I've been using them since 2016. They're still going strong. They're wonderful. But I'm here to learn more how to use them.
Oh yeah, and like I said, mine, I don't even know how many hours I put into them, but I just change the batteries once in a while. And if you want to handle them, I mean, they're really heavy. They're magnetic, and like I said, they've got that switch on it, so you can do all kinds of neat things with them. And if anybody wants the plans to this, if you want to, let me see. I think I might have my email on this. I don't think I have my email. If you go to my website, you can contact me, hit the contact, and just let me know that you guys were at the thing. I'll send you this. I'll send you guys, I'll actually send you guys plans for my gravity well as well. So I have a big gravity well that you can build. It's a lot cheaper than the one that a certain company has, okay?
What's that one called? The sound?
This is Seeing Sound.
Seeing sound.
This is just Seeing Sound.
If you